The melted and broken lug indicates excessive heat buildup, which can lead to further overheating and even a fire. The incorrect conduit size and number of conductors in the conduit will cause excessive resistance and heat buildup. The 1/0 conductors are not rated for the full 225 amps load. When paralleled with the number 1 conductors, they will carry a disproportionate amount of current. This uneven distribution can overload the 1/0 conductors and cause them to overheat. The excessive heat buildup can damage the insulation on the conductors, leading to short circuits and further safety risks. The excessive current flow can damage the connected equipment, such as the breaker and the equipment it feeds. The 1/0 conductors will carry more load than the number 1 conductors due to their lower resistance. This will cause the 1/0 conductors to overheat and potentially fail before the number 1 conductors. The number 1 conductors may carry minimal current and not provide sufficient power to the equipment. To mitigate this, firstly, replace the melted and broken lug. Install a new lug rated for the full 225 amps load. Secondly, install a new conduit and wires. The conduit should be sized to accommodate the number and size of conductors according to National Electrical Code requirements. Thirdly, ensure that the conductors are properly paralleled and that the load is evenly distributed. Fourthly, verify that the breaker or fuse is sized correctly for the load. And fifthly, ensure that the system is properly grounded. Paralleling conductors is a common practice in electrical systems to increase the current carrying capacity of a circuit. However, it must be done correctly to avoid potential hazards. Several factors must be considered to ensure that paralleled conductors share the load equally and operate safely. These factors include conductor size, length, material, insulation, and termination. The National Electrical Code, or NEC, provides specific guidelines for paralleling conductors. These guidelines are designed to ensure that the conductors are installed safely and that they will function properly. According to NEC Section 310.104, conductors size 1/0 American wire gauge, or ALC, and larger are permitted to be run in parallel. All the following requirements must be met. Firstly, all the parallel conductors must be the same length. Unequal lengths can lead to differences in impedance, which can cause unequal current sharing. Even small differences in length can have a significant impact, especially in circuits with high current. Secondly, the conductors must be of the same material. Copper and aluminum conductors have different resistivities. If you mix copper and aluminum conductors in parallel, the copper conductors will carry a larger share of the current. Thirdly, conductors must be the same size and circular mill area. The circular mill area is a measure of the conductor's cross-sectional area. Conductors with different circular mill areas will have different resistances, which will lead to unequal current sharing. Fourthly, conductors must have the same insulation type. Different insulation types have different temperature ratings. If you mix insulation types, the conductor with the lower temperature rating may overheat. And fifthly, conductors must be terminated in the same manner. The terminations must be properly torqued to ensure a good electrical connection. Loose or corroded connections can create resistance, which can lead to unequal current sharing and overheating. In the scenario described, the use of 1/0 AWG and number 1 AWG conductors in parallel violates several of these requirements. The conductors are not the same size, and this difference in size will cause an unequal distribution of current. The 1/0 AWG conductors, having a larger cross-sectional area and lower resistance, will carry a disproportionately larger share of the current compared to the number 1 AWG conductors. This can lead to overloading of the 1/0 AWG conductors, causing them to overheat and potentially fail. Overheating is a serious issue. Excessive heat can damage the insulation on the conductors, leading to short circuits and ground faults. It can also create a fire hazard. The melted lug that was discovered is a clear indication of excessive heat buildup. The lug is the point where the conductor connects to the breaker. If the connection is loose or corroded, it can create resistance. This resistance generates heat, which can melt the lug and damage the breaker. The fact that the lug melted and broke loose is a sign that the circuit was severely overloaded. In addition to the unequal conductor sizes, the conduit size is also a concern. The NEC specifies the maximum number of conductors that can be installed in a conduit of a given size. The purpose of these requirements is to ensure that there is adequate space for the conductors to dissipate heat. When too many conductors are packed into a conduit, the heat cannot escape and the conductors can overheat. The fact that there are 6 conductors in a 1 1/2 inch conduit suggests that the conduit is undersized. This would further exacerbate the overheating problem. Given these issues, it is essential to take corrective action immediately. The following steps should be taken. Firstly, disconnect the circuit and make it safe to work on. Secondly, remove the existing conductors and conduit. Thirdly, install new conductors of the correct size. The conductors should be sized according to the load requirements and the NEC ampacity tables. Fourthly, install a new conduit of the correct size. The conduit should be sized according to the number of conductors and the NEC fill requirements. Fifthly, terminate the conductors properly. The termination should be properly torqued to ensure a good electrical connection. And sixthly, test the circuit to ensure that it is working properly. After completing these steps, the circuit should be safe and reliable. It is also important to address the underlying cause of the problem. In this case, it appears that the circuit was overloaded due to the addition of new equipment. Before adding new equipment to an existing circuit, it is important to perform a load calculation to ensure that the circuit can handle the additional load. If the circuit is already near its maximum capacity, it may be necessary to install a new circuit to serve the new equipment. The National Electrical Code is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. Electricians and electrical contractors are required to follow the NEC when installing electrical systems. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. The NEC covers a wide range of topics, including conductor sizing, conduit fill, overcurrent protection, grounding, and bonding. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. It is important for anyone working with electrical systems to be familiar with the NEC. The NEC is available for purchase from the National Fire Protection Association, or NFPA. It is also available online through various subscription services. In addition to the NEC, there are also state and local electrical codes that must be followed. These codes may be more stringent than the NEC. It is important to check with the local authority having jurisdiction, or to determine which codes apply in a particular area. The HA is the government agency responsible for enforcing electrical codes. The HA may be a city, county, or state agency. The HA has the authority to inspect electrical installations and to issue permits. It is important to obtain the necessary permits before starting any electrical work. The HA can also provide guidance on interpreting the electrical codes. Working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock and other hazards. Always de-energize a circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not qualified to work on electrical systems, hire a licensed electrician. A licensed electrician has the training and experience to safely install and repair electrical systems. Hiring a licensed electrician can help to ensure that your electrical system is safe and reliable. The cost of hiring a licensed electrician may be higher than the cost of doing the work yourself, but it is worth it to protect yourself and your property. In summary, the situation described involves several violations of the National Electrical Code and poses a significant safety hazard. The unequal conductor sizes, undersized conduit, and overloaded circuit all contribute to the risk of overheating, fire, and equipment damage. It is essential to take corrective action immediately to address these issues. This includes replacing the conductors and conduit with properly sized components, ensuring that the load is evenly distributed, and verifying that the overcurrent protection is adequate. By following these steps, the electrical system can be made safe and reliable. Remember, electrical safety is paramount. Always follow the NEC and other applicable codes. If you are not qualified to work on electrical systems, hire a licensed electrician. Ignoring these safety precautions can have serious consequences. The information provided is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before making any changes to your electrical system. They can assess your specific situation and provide guidance on the best course of action. The importance of proper grounding and bonding cannot be overstated. Grounding provides a path for fault current to return to the source, which helps to trip the overcurrent protection device and clear the fault. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and reduce the risk of electric shock. The NEC has specific requirements for grounding and bonding. These requirements are designed to ensure that the electrical system is safe and reliable. It is important to follow these requirements carefully. Improper grounding and bonding can create a dangerous situation. In addition to the technical aspects of electrical safety, it is also important to be aware of the human factors. Electrical accidents often occur due to carelessness, lack of training, or fatigue. It is important to be alert and focused when working with electricity. Take breaks when you are tired. Never work on electrical systems while under the influence of drugs or alcohol. Following these simple precautions can help to prevent electrical accidents. The electrical industry is constantly evolving. New technologies and best practices are constantly being developed. It is important to stay up to date on the latest developments. This can be done by attending training courses, reading industry publications, and participating in professional organizations. By staying informed, you can ensure that you are using the latest and most effective methods for installing and maintaining electrical systems. In addition to the NEC, there are also other standards that may apply to electrical installations. These standards may be developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. These standards provide guidance on specific aspects of electrical design and installation. It is important to be aware of these standards and to follow them when applicable. The electrical system is a critical part of any building. It provides power for lighting, heating, cooling, and other essential functions. It is important to maintain the electrical system properly to ensure that it is safe and reliable. This includes regularly inspecting the system for damage, replacing worn or defective components, and performing preventive maintenance. By maintaining the electrical system properly, you can help to prevent electrical accidents and ensure that the building is safe for occupants. The use of arc fault circuit interrupters, or size, and ground fault circuit interrupters, or GFCIs, is becoming increasingly common in electrical installations. Size protect against arc faults, which can cause fires. GFCIs protect against ground faults, which can cause electric shock. The NEC requires the use of size and GFCIs in certain areas of the building. It is important to understand these requirements and to install these devices properly. The use of surge protected devices, or SPDs, is also becoming increasingly common. SPD protect against voltage surges, which can damage electronic equipment. Voltage surges can be caused by lightning, utility switching, or other events. SPD are typically installed at the service entrance of the building. The NEC provides guidance on the selection and installation of SPD. The importance of energy efficiency is also growing. Energy-efficient electrical systems can save money on utility bills and reduce environmental impact. There are many ways to improve the energy efficiency of an electrical system. This includes using energy-efficient lighting, installing occupancy sensors, and optimizing the size of electrical equipment. The NEC provides guidance on energy-efficient electrical design. The use of renewable energy sources, such as solar and wind, is also becoming more common. Renewable energy sources can reduce reliance on fossil fuels and lower carbon emissions. The NEC provides guidance on the installation of renewable energy systems. In conclusion, the electrical system is a complex and important part of any building. It is important to understand the principles of electrical safety and to follow the applicable codes and standards. By doing so, you can help to ensure that the electrical system is safe, reliable, and energy efficient.